See what happens here. Connecting live video. Looks like we're about to go live here on YouTube. And I just got to hit our go live button on Facebook. I think we're live on YouTube at the moment. And we're just taking a second here to make sure that we're live on Facebook. Folks, you just hang on a sec. Looks like we're up and running.
I see us on Facebook.
Perfect. I see us on YouTube, I think. Alrighty. Well, good evening, everybody, and welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. And first of all, I'd like to welcome back Royal Astronomical Society of Canada NB chapter members, Paul Owen from the Moonshadow Observatory in Hampton. Hey, Paul. Hiya, Paul.
Big finger.
And we've got Mr. Mike Powell from the PFO Observatory in St. John. Welcome, Mike.
Salute.
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 Hello.
Hey, and happy Thanksgiving, everybody out there, for sure. If you celebrate today or tomorrow, happy Turkey Day. Whatever day it is, I'm sure you're going to have leftovers for the rest of the week. So that's how it usually works. So be prepared for some nice naps, as turkey does to you. Anyway, so tonight we've got another mixture of topics here to discuss for you tonight. First of all, we'll get started with a little bit of a look at what's up in space this week. Then Mike is going to present the second segment in our brand new segment we're calling the Gearbox, where this week Mike will give an unboxing and a review about a new set of planetary filters he received.
Yay!
Hey! Mailman loves Mike's house. Always guaranteed a job.
Employment equity.
And we're hoping also to offer some live views tonight. Paul and Mike are setting up there now. Mike is set up on a target, and Paul is working on some double stars for us. He's just doing some plate solving and setting up there now for us. So be a little bit for that. But Paul's got lots of time here to get ready. And they're going to offer some live targets through their telescopes tonight of some objects known as double stars. And we've also got planetary nebula here as well. Now, some of these are what we call optical doubles, meaning that they appear to be related from our point of view. And others are really true binary stars, where they actually orbit around a common center of gravity. Some of these star sets can be quite striking in our color, so we hope to offer you a few of our favorites here tonight. And we may also get a chance to view, well, we're not going to get a chance to view Jupiter. I guess we were looking at that earlier, but probably not at the moment. Might not be high enough in our sky right now, but we'll have lots here for you anyway. Also, Paul's going to be presenting our Rosanna's Fun Facts segment once again, and of course, we'll have your photo submissions for the week. And we're hoping to have some time at the end of the show, maybe to talk about what's coming up in the night sky as well. So another pretty full show on the way, so sit back and enjoy. Remember, this is a live broadcast, so if you have any questions about the night sky, we're happy to try and answer them for you. And so before we get started, though, with the show, we do have a little bit of an announcement to make. Let's say hello to everybody out there, first of all, in Facebook and YouTube land. Trudy's on in YouTube. We got Kaylee, and we have Peter and Emma and Greg. Good evening, everybody. Thanks for joining us. Okay, what's been happening over the last week? Well, I'm going to share my screen here, guys, if you don't mind for a second.
Yep.
And so I can fill them in on what was going on this week. We're going to go with this one, I guess. And I just need to come over here and open up my folder. And this one. Okay, well, what happened this week? Oh, where's my mouse? Here, I got 5 monitors on the go. So hopefully we can see that. This is Shelley Steeves. This week, Mike and Paul and I were interviewed by a global news reporter, Shelley Steeves, and the interview was about our Sunday night offering here on the Sunday Night Astronomy Show, which was a lot of fun doing the interview, and how we're all members of the Royal Astronomical Society of Canada, and how we are trying to offer something very special that can help fill the void for many who are missing contact and camaraderie and nature and museums, etc., all due to COVID. Well, the interview will be broadcast tomorrow out of Toronto on Global National TV. And their morning show will start at 7 a.m. Atlantic time, as they are broadcasting nationally tomorrow instead of locally due to the holiday. So we're really not sure when the segment's going to air. It is up to the producer, and it will depend on what news happens overnight. But These are the hosts, and I know that it'll be on somewhere between 7 and 10 a.m. That's all I can say at the moment. I know that most may be sleeping in on the holiday, so I've been told that I can get a link to the segment once it airs, and I will post it here up on my page tomorrow once we get it. So we were interviewed on just our astronomy our Sunday night astronomy show, and how we're enjoying it, and what kind of an audience we're reaching, that type of thing. So we're really looking forward to the segment. We have no idea what it looks like. Our apologies ahead of time if it happens to be an embarrassing moment or two. But we would like to thank Shelley and Global TV for their interest in our story so far. It was a lot of fun to do the interview, and we do hope you guys like it out there. With COVID happening right across the country right now, almost no personal outreach is happening. But for those who are tuning in from outside New Brunswick, I did want to mention as well that we do have local centers throughout the country that have virtual public events taking place right now. Also, RASC does have a number of good clubs to join to meet people with similar interests from all backgrounds and ages. So if you are looking for information on how to join one of our centers, just go simply to rasc.ca and look under the Society button for information on one of our 30 centers across the country. So that's what's been happening this week for us. Yay!
Yep. Busy week.
So we're looking forward to seeing how this all plays out. And
5 minutes of fame.
5 minutes of fame, maybe 5. Oh, Peter says, I hope you guys weren't wearing your hats for that TV. Of course we were, Peter. We had to be ourselves.
I need my space.
We need our space. That's right. Anyway, we're really looking forward to the results of the interview. It was a lot of fun doing it, and we'll see what happens. Okay, so let's get to our space stories for the week. What's new in space this week? Give me a second here. I'll try to bring us up again. All right, let's get us over to, I'll try to present my screen again, guys. Now I'll got to drag things from one place to the other. And see if I can get this one up first of all. I've got videos open here all over the place. I'm running with 5 monitors at the moment, so one of my monitors has 12 tabs open right now. So still trying to get stuff properly for the show. So let me bring this one over to here, and we'll see if you can all see it first of all. Oh, let's get it over to the right screen. I got to drag and drop it over to here. And then we're going to go do this. And we're going to talk a little bit about this. So here's some spooky sounds coming from the Parker Solar Probe, NASA's Parker Solar Probe. The scientists have studied the solar wind for more than 60 years, but they're still puzzled over some of its behaviors. NASA's Parker Solar Probe hears these small chirps, squeaks, and rustles that hint at the origin of this mysterious and ever-present wind. Hopefully you can hear that out there. Pretty spooky stuff. And now the Parker Solar Probe team is getting their first chance to hear them too. And there's a wind that emanates from the sun, and it blows not like a soft whistle, but like a hurricane scream. Made of electrons, protons, and heavier ions. Let's play that over again. The solar wind courses through the solar system at roughly 1 million miles per hour, or 1.6 million kilometers per hour, barreling over everything in its path. The Parker Solar Probe is scheduled to make another 21 orbits around the Sun, using 5 Venus flybys to draw itself increasingly closer. That will allow researchers to even better understand how these waves change their behavior closer to the Sun, and allow scientists to build a more complete evolutionary picture of the solar wind. I thought that was pretty neat. Anyway, we'll talk about Carl Sagan later. And next up, just get myself on the right screen. Oh, is that one going to go? Yes, it is. Okay. Well, astronauts on NASA's Apollo missions on the moon captured astounding movies of the lunar surface. Turn that volume down a bit.
That's. 'Take 'em. 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 'Take 'em
Recently, enhancements with artificial intelligence have really made the films out of this world. In remastered movies shared online by Dutch Stream Machine, a YouTube channel run by a film restoration specialist in the Netherlands, details from lunar scenes are astonishingly crisp and vivid. From Mission Commander Neil Armstrong's first steps on the moon in 1969 to bumpy lunar rover drives during the Apollo 15 and 16 in 1971 and 1972. This is clips from the 1972 mission, Apollo 16. The film restorer behind Dutch Steam Machine, who also goes by Niels, used AI to stabilize shaky footage and generate new frames in NASA's moon landing films, increasing the frame rate, the number of frames at play per second, smoothed the motion, and made it look more like movement in HD video. When old films are shot at lower frame rate are displayed at higher rates, the motion appears sped up and jittery, which creates a disconnect between the past and the person watching, Niels told Live Science in an email. Experts have been remastering old films for decades, but the recent addition of AI has taken results to a new level. Niels hopes that these videos will bring the moonwalks just a little bit closer to Earthbound viewers and help them to see and appreciate these landmark events as the astronauts did. He also hopes the remastered footage will inspire more interest in space agencies' upcoming plans for launching crewed missions that fly beyond low Earth orbit and even return to the lunar surface while equipped with cameras capable of shooting in HD.
Okay, here's the Sharpie. Hey, that's great.
This is awesome footage. Now, wouldn't you love to be doing that?
Man, those things.
He's actually drifting around some of the corners.
He's got one point there where all four wheels are off the ground.
Yeah, that's awesome.
Like the way that he's redone these clips is amazing, and he's got a whole pile of them out there right now.
Call that a Grand Prix.
The ultimate ATV.
It's called the Dutch Steam Machine. That's the name of the YouTube page. Yeah, there it goes. Now watch the dirt.
Okay, I don't want to do that.
Okay, anybody who wants to talk about conspiracy theories and are not on the moon, find myself a soundstage that big first of all, and then find me one that allows the dirt to do that.
Okay,
So watch the dirt coming off the tails of that clip. I'll go back here in a second. Watch the dirt come off the tails and watch the dirt fall directly right down. It doesn't stay, it doesn't remain in the air, and it can only do that in a vacuum.
One more time. Yeah, about a minute, 5 seconds that time. Mark on.
We'll see it again here when he spins around.
Okay, you could have gone the other way. Go ahead. There's the big craters there, though, aren't they? Yeah, I know.
See the dirt that's coming up off one side and just falling right down again. And even the rooster tails only remain for a second or two.
Well, it's a minute and 5.
If you were driving across the desert with that, you wouldn't even be able to see that rover with a cloud of dust.
Okay, turn sharp.
So there you are. There's your proof.
Proof's in the pudding.
Proof's in the pudding.
Hey, that's great.
Anyway, another nice clip. And we'll carry on here. Continue on. Next part of the story. This guy. Tom Cruise will fly to space to shoot his record-breaking film project. With the help of Elon Musk, the Mission Impossible actor, 58, will make the trip with director Doug Liman to film scenes of the currently unnamed movie. As reported by Space Shuttle Almanac, Cruise and Liman will travel to the International Space Station in the Axiom Space Crew Dragon capsule, owned by Musk's SpaceX company in October 2021. Reports say that there is space for one other person on the flight, suggesting that another cast member may join them on their journey. Well, the film was announced in May when NASA Administrator Jim Bridenstine tweeted that he was excited to work with the crews on the project. As well as directing, Lehman is said to be writing the script, with him reporting in July that Universal Pictures have pledged an estimated $200 million to the production. Yes, sir. And finally, a Utah man is behind bars after he stole a pickup truck out of a 7-Eleven parking lot. Well, the victim left the keys in the truck and the vehicle unlocked when he went into the convenience store for a quick stop. That's when Bryce Gerald Dixon hopped into the vehicle and took off. Now, apparently, Dixon took the truck in order to drive all the way to the Coliseum to get on a flight with alien diplomats. Unfortunately, before Dixon could get to the Coliseum, which was some 6,000 miles away across the ocean, he started to feel bad and decided to return the red pickup truck to the parking lot and its owner, where the police were waiting. Well, Dixon was then transferred to a nearby hospital for treatment after the truck owner punched him in the face upon returning the vehicle. While at the hospital, Dixon also tried to escape 3 times. Anyway, and that's what was happening this week in space.
Hey.
Hey, you guys still there?
Yeah.
Hey, here he is.
That's a nice truck.
That's a nice truck. You picked up an alien spacecraft, yeah. Who we got out there now? I saw Orion for the first time for the season this week. Marlene says, "Cool, yeah, it's going to be up there a lot more. It's coming around again."
Tis. So's the snow.
It's right. Alrighty, so we're back to our category. Now we're going to go from here. Do we want to do a show of a livestock, or do we want to do your talk, Mike? How about the gearbox talk?
Yeah.
Oh, pick one. What would you like?
Gearbox.
Gearbox
Give
sounds
me
good.
one. All right.
Gearbox sounds good.
Let me
Let me stop. I'm stop presenting. Yeah, good. Okay. I want to get rid of that meeting details at the top.
tilt the camera down. There I can. It might be a little crooked. There, yeah.
Oh,
Okay.
wait now. Hang on a second before we start. Emma's asking, where's Darth Vader and Stormtrooper?
Oh, well, yeah.
Yeah.
They got a new friend. They decided that they wanted to stand up taller than him. So
They're there. Never fear, Emma. They're always there.
there we go.
Classic.
You get all that noise. Alrighty.
Are you want to pin you, Mike, or?
Sure, if you like.
Sure. Okay, go ahead. Yeah.
I don't know if this is considered an unboxing or an unbagging, but this came in the mail for me the other day. I ordered a set of planetary filters out of England. I did rip it open, but I haven't partake yet in seeing what was inside, so I hope it's what I ordered. So I just thought tonight's show I would do an unboxing of these planetary filters that I bought. They're 2-inch from, I got them on eBay, but they're out of England. So we'll reach in the pack and see what we got. Alrighty. Nice cardboard box they put them in. I don't know how you open these things. I got no fingernails. We'll slide them out. And they come 4 in a case. So the simple planetary filters, a red, a blue, a yellow, and a green. They're 2-inch. I don't know. I didn't have any actual 2-inch planetary filters. I had all 1 1/4. So excuse me. So I thought for the first time I'd finally order these. These were $32 Canadian, and I think $6 to ship from England. Nice to see they're nice and crisp and clean. No fingerprints on them. No marks on them. Which you expect to get when they're brand new, but on eBay you never know what you're going to get until it shows up. Again, with Mars out, this orange filter they say or the red is really good for looking at Mars. It brings up the contrast, but they say your best views are actually by using a blue filter on Mars. And you'll see the white polar cap stand right out like it was, sitting on your front doorstep. So I can't wait. I want to get these out and try them. It was a quick set. I ordered a separate orange one. I've got an orange one coming because I thought if everything else, this is the basic colors, but it'd be nice to have an orange one as well. So they don't sell a kit of 5. They only sell a kit of 4. So I bought these 4 planetary filters, and I ordered an orange one separate. So I'm looking forward to using them. On my 50 millimeter eyepiece, 2-inch, and I'll pass on later what the views were like because I've been kind of pushing planetary filters lately and we'll see what we get. So there's my quick little shot of my 2-inch filters that I ordered off eBay. Like I said, they're planetary filters, the 4 basic colors: blue, yellow, green, and red. I could go through and find my list of what the different colors are supposed to accentuate on the planets. But you can look them up on Google. Anybody can just say, what's the best filters for looking at Mars? What's the best for looking at Saturn, and so on. And they'll tell you. There's a whole list out there that'll tell you what these are best used on or for. But for $40, it's cool to have a good set. That's less than $10 a filter when you break it down. That's not a bad purchase. So there you go. That's our gearbox talk of the day. Nice and short, quick, and easy. And I get to play with my new filters. Can't wait.
Just the way you like the talks. Nice and short and easy. Awesome, Mike.
If you
Thank
like,
you.
yeah, I've been on this object since we started tonight. If you want to see
Sure.
a live view,
Absolutely. Let's get out of
let me see if I can share my screen. Present now. We want entire screen, right?
Mm-hmm.
And I believe it's this one because it's the only one with a space picture on it. And we should see the M17. Did it come up?
We do. I'm seeing a couple of comments on Facebook. I'm just wondering if somebody could comment back to me. I asked if are others able to see comments here tonight. There are a few that are saying that they can't see all the comments. I'm not sure what's going on with Facebook again. I love Facebook.
I'm
You
showing
think
22 comments so far on Facebook.
Yeah, and I'm seeing them here as let's say of the 5 monitors, one broadcasting out. I can see the 2 live feeds that are coming back to me, and
Yeah.
they both look like they're both up and communicating okay. I'm not sure if it's your issues with Facebook or whether it's because I'm using the classic style Facebook, and maybe next week I'll try upgrading to the new one. Because I'm still allowed to go back to classic, I keep doing it because I don't like to change. And that might be the issue. So I'll experiment with that this week and see if that's the problem. Anyway, let's get back to our topic here. We're showing the Swan Nebula right now.
Yeah, if you want to pin that maybe and show it full screen.
Sure. Up to.
Excuse me.
There we go. So we are talking about the Swan Nebula at the moment. What is the Swan Nebula?
Or Omega, yeah.
Or the Omega, right? It's one of the brightest and most massive star-forming regions in our galaxy. The Omega, or the Swan Nebula, came to resemble the shape resembling a swan's neck that we see today, only relatively recently, actually. New observations reveal that its regions formed separately over multiple areas of starbirth. The present-day nebula holds the secrets that reveal its past. We just need to be able to uncover them. Uncovering the nebula's secrets is no simple task. It's located more than 5,000 light years away in the constellation of Sagittarius, and that's where a lot of the deep sky treasures that we like to offer are located. That's not very high in Sagittarius, is it, Mike? So you're able to get that view. Not bad.
It's just over the roof of my house, actually.
I wanted to make sure people know that this is a live view right now. So, are you able to show your setup, Mike? We can get to that maybe.
Outside or
Yeah, can you do that or?
see if I can find it.
Okay. We'll show you how this is being captured live.
Minimize this. Desktop.
Like it's pinned here right now, so I'll have to unpin
Yeah,
it.
I'll just drag. Once I get it, I'll drag it over.
Okay.
Probably find a raccoon riding side saddle on it or something. Come on. There
Hi,
we
Paul.
go.
Hi, Paul. Hi, Paul.
That over if you can see it.
Quiet. No.
No, hold on.
Okay. Hold your pickle.
How about that one?
There we go. That's got it. All right.
That's
So this is the inside of Mike's observatory at the moment, and look at how low the scope is to catch Sagittarius in areas Sagittarius. For us now, Sagittarius is getting a lot lower early evening. as we rotate around and we start to get, I mean, we're continually orbiting the sun, of course, but we're starting to look at different pieces of the sky. So Sagittarius is over in our southwest now, getting very low, and so is Jupiter and Saturn, and they'll be much lower come December for sure. But we're starting to see our wintertime constellations start to pop up as well. So Mike is just above his roof line, looks like, to catch
Yeah, I'm
this.
probably a foot above the roof line, maybe up in here somewhere.
Okay, let me see if I can bring up a picture of where that is, Mike. So people, or maybe you can bring it up on your screen, can you? Where we're looking?
Yeah, just give me a second. I can throw this out of the way. And should be this here. So there's due south is this line in the center.
Mm-hmm.
And M17 is just off the side of it.
Just below that is Sagittarius. Are you able to bring the constellations on, or do we? Yeah, we can see it there, I guess. Yeah.
There, yeah.
Yeah.
So there's Sagittarius right here in the circle. There's Ophiuchus. M17 sits right between the two. So we're looking right in this area, and I don't know what it is. 20 degrees above. Is that the second line?
Yeah, roughly. I think. Yeah.
23 degrees maybe above.
Yeah. So not very high.
7.
Not very high for sure.
22 degrees, Mike.
Yeah, but it's at least it's over the roof of the house. I'm not hitting the house. So.
Yeah. Yeah, if you put your when you put your cursor right over top of the target, look down in the bottom right left-hand corner, and it'll give you your degree in altitude.
Oh yeah.
Or if you're using oh good golly, Miss Molly, ASCOM, it's right on your ASCOM controller, like that control stuff right on there.
Yep.
Yep, either of those give you your degrees.
So yeah, what 22.3 ish.
22, yeah, yeah, that's pretty darn low.
So that's
A
four.
really good image for something that low.
Yeah, that's about 4/5 widths up from the horizon. So it's not very high when you're trying to get an image like that, for sure. Lots of nice stars there too, Mike. So we're looking back into the area of the center of the Milky Way when we're looking into this direction. This is why we have so many targets in that section of the sky. It's really, we're looking downtown New York City basically, and all the tens of billions of stars that sit at the center of our galaxy. And there are many more objects right in that area that we're able to pick out too.
I'm surprised. It's a nice, bright, easy target to get on too. Like before it actually got dark, I was starting to pick up the nebulosity on the screen, so it was easy to nail because it is so bright. I was quite impressed how much brighter it is than other objects out there.
It's a good one for star parties.
Yeah.
It is so bright.
Yeah, absolutely. Yeah, it is so bright. I mean, Orion would be nice too, but we don't have any winter star parties, so probably a good thing. Kaylee, there was a comment here. I'm looking on YouTube. Michael Stewart, thank you, Michael, for the comment there. He says, I checked my Facebook new layout. Everything looks okay. Comments are showing for me, so I'm not sure, Kaylee, if you are on the new, quote, new Facebook or the old classic one. But like you say, all that matters is that we can see and hear you. I guess that's most important. We're happy to see your comments. I'm seeing your comments, so if you want to comment at all, I can see them here, so no worries. And I will pass on anything that people would like to pass on here. Tanya did mention about the CBC interview that was done last week. Unfortunately, Tanya, I did mention that CBC only shares a few other clips from each show, and there were other topics chosen for that one, but I've been up on other ones, so. But I guess the bigger one is tomorrow, so we're all kind of, well, I'm a little bit nervous about it, how it turned out, but I know it was a lot of fun. Anyway,
it's called too late now.
yeah, that's right. Well, once the reporter left the driveway, that was it. It's done.
But
You've already written the test, so now you just got to wait for the marks, right?
That's it. $20 to see her to her car to cut me out of it. So.
Yeah. You were in there pretty good. So this is located more than 5,000 light years away in the constellation Sagittarius. Its center is filled with more than 100 of the galaxy's most massive young stars. These stars may be many times the size of our sun, but the youngest generations are forming deep in cocoons of dust and gas where they are very difficult to see, even with space telescopes. Because the central region glows very brightly, the detectors on space telescopes were saturated at the wavelengths similar to an overexposed photo. New central region is the oldest, most evolved, and likely formed first, and then the next the northern area formed, while the southern region is the youngest. Now that's actually flipped upside down, I guess, Mike, is it? Is this the way
Uh,
that,
I guess, yeah.
even though the northern area is older than the southern region, the radiation and stellar winds from previous generations of stars has disturbed the material there, preventing it from collapsing in to form the next generation of stars. Massive stars like those in the Swan Nebula release so much energy that they can change the evolution of entire galaxies. But less than 1% of all stars are this enormous, so astronomers know very little about them. Now, previous observations of this nebula looked at different areas of it in different wavelengths of light. Spitzer has been looking at it for a while now. This is another Spitzer is an infrared telescope, and it helps. Spitzer has the ability to be able to strip away these large clouds of dust and gas that we see that are blocking a lot of the starlight behind them, and it can strip them away and see what's behind them, and it gets a much better view than. But they're billions of dollars of telescopes too, and we're still getting a live view here, so this isn't bad, I'd say.
Now you'll see a yellow bar going across the top. It's dropping some frames because I actually paused the stacking.
Mm-hmm.
So just every time another minute goes by, it puts that yellow bar across the top, which is quite annoying.
So you're stacking every minute, right, Mike? In this case? Okay, so what Mike is doing is live stacking. So he's taking a picture basically every 1 minute, every minute. He takes a snapshot of the sky, and then a minute later he takes another snapshot, and another, just continues like that. So it's what we call live stacking. And those pictures are stacked on top of each other, and as you start to stack those images, the detail starts to become better and better from the objects that we see. Again, now this is 5,000 light years away, and each light year is 1 trillion or 10 trillion kilometers. Sorry.
I have to apologize. I'm stacking every 30 seconds, not every minute.
Okay. So the image that we're seeing here is actually 5,000 years old because the photons of light left that nebula 5,000 years ago, traveled towards our eyeball at the speed of light, and ended up on Mike's camera chip tonight, and he's displaying it across these images. So we're seeing this nebula as it was 5,000 years ago, and it's a difficult concept to grasp. I know that when you're looking up in the sky, you are really looking back in time. It doesn't matter what the object is that you're looking at, you're still looking back in time. Even the moon, when we look at the moon, it's not the way the moon appears at that instant. It's actually the way the moon appears 1.5 seconds ago, because it takes light light travels at 300,000 kilometers in 1 second. The moon is roughly 400,000 kilometers away. So we see the moon as it was 1.5 seconds ago. Now, if we were to talk about the sun is actually 8.33 light minutes away. So we see the sun as it was 8.5 minutes ago. The next closest star would be Proxima Centauri, which is 4.3 light years away. So if we see that in our sky, then we see it as it was 4 years ago. This nebula, we're seeing it as it was 5,000 years ago. And these are photons of light that are traveling at the speed of light, of course, through space and entering the camera or chip on Mike's camera right now. Well, this is barely visible to the unaided eye on a dark, moonless night, but it is visible. It's best seen through binoculars, actually, or low power on a telescope. What are you running for focal length on your scope, Mike? This one?
770.
770, so that's pretty low. It's very near another prominent nebula as well, called the Eagle Nebula. It's home nebula of the famous pillars of creation that we see in the Hubble famous images. Now these two closely knit patches of haze readily fit within the same binocular field of view. So if you know exactly where to look, you'll find them. Just above the you're looking just above the lid of the teapot of Sagittarius. And if you want to find deep sky objects like this one, learn to recognize the constellation Sagittarius, the Archer. It's located in the direction of the center of our Milky Way. And many beautiful star clusters and nebula can be found in this part of the sky. Luckily, this constellation contains an easy-to-find star pattern, or an asterism we call it, in the shape of a teapot. And asterisms, of course, are not constellations, but they remind us of particular shapes. And we have the Big Dipper, we have the Little Dipper, the Great Square of Pegasus, the Circle of the Stars around the ring of around Polaris, that type of thing. This one is called the Teapot, and it's Sagittarius, the Archer, and it's fairly easy to star hop up to the Omega Nebula and its companion right beside it. So from the Teapot, you just draw an imaginary line up, and just to the left. To locate M16 and M17, which is what these are. M16 is the Eagle Nebula, M17 is the Swan, the one we're looking at now. As seen from the northern hemisphere, the teapot, M16 and M17 are normally summertime objects. They're highest up due south on late August evenings. And at the same time, they're wintertime objects from the southern hemisphere, where they're found closer to overhead. Now, like M16, M17 is this one we're seeing now, the Swan Nebula. It's also called the Omega Nebula. It's a vast interstellar cloud of dust and gas giving birth to young, hot suns. It spans some 15 light years in diameter. That's amazing. 15 light years. So 4 times the distance to the closest star. 15 times 10 trillion kilometers. It has a mass of roughly 30,000 solar masses. The total mass of the Omega Nebula is estimated to be about 800 solar masses. The distance to the M17 Omega Nebula isn't known with precision. There is little doubt that it lies farther away than the Great Orion Nebula for sure. When you're looking at either the Eagle Nebula or this one, the Swan Nebula, you're gazing at deep sky wonders in the next spiral arm inward, the Sagittarius arm of the Milky Way. Any questions about the Swan Nebula and how we're capturing it? Anything else? Looking for questions on Facebook and YouTube, and all looks good. I guess people are just enjoying the view, the live view from St. John.
You know, I don't know if you mentioned it or not, but he's right in the middle of the city.
True. That's true.
And have a look at what you're getting there. So, I mean, if you're going to go out and observe, certainly you want dark skies. But if you want to observe through the use of a telescope and a camera, you can do it right from the city, because Mike's showing us here right now. There's a beautiful image of the Swan Nebula that it would be rivaled to see through the telescope. So, and here he's doing it right in the middle of the city.
Absolutely.
So yeah.
Yep.
I think in that direction right now, my scope's pointing right over top of the pulp mill. It's split up pretty good at night.
That's what all that smoke is. Okay.
Oh, I
That's
smell
not
something.
nebula at all.
That's not nebulosity.
That's money.
But that's pretty amazing when you think about that. So a lot of people think, well, seeing as that I live in the city, I don't want to bother getting into astronomy and never see anything. But here you are, right?
Yeah, it is impressive what you can get. And the only thing I'm running on there is a moon and sky glow filter at this point.
Yeah.
Which supposedly takes out some of the sodium and mercury lighting, I guess.
Mm-hmm. That's your 294 camera, Mike?
That's the 294, yeah. And it's that Orion 110 millimeter APO with the 770 millimeter focal length. Now this is unguided tonight too because I couldn't get my guide camera connected for whatever reason. So
Yeah.
the sharp
But
cap will stack on top of each other and line it up anyway.
yeah, and you could get, once you get your guiding going, you could get that, excuse me, a lot deeper. But even when you look at how faint the stars are, and I'm noticing if you look to the just a little bit to the left and down, you're starting to see a lot of the fainter nebulosity coming out.
Here and then
Yeah, it's really, really impressive. It's really impressive. So if you want to sit in the comfort of your home in front of a screen, if you have a scope, you can set up outside. My gosh, you can enjoy the sky all night long and look at all these wonderful targets in full color. Because if you were looking at that through a telescope, you would see it, but it would appear to be just like a grayish kind of a smudge. But here you're seeing the color, you're seeing the color in the stars, and it's really impressive. Like I sit back and I'm just shaking my head thinking, can you imagine like 30 years ago if you could do this?
oh yeah,
Awesome, yeah. Yeah, I mean, how far we've come in 30 years, just think about it. I mean, observatories were the only way that you get any ton of a native like this, even 30 years ago. But it's amazing you can do this from your own backyard now. Hello, Ann from Connecticut, USA. Welcome.
Hey.
Hey.
hey,
She says, so beautiful. Hi from Connecticut, USA. Welcome. So yeah, this is also called, I guess, the Horseshoe Nebula. Didn't know that. I did not know that.
I did not know that. Must be
Johnny?
right in here, maybe.
Yeah, maybe in the Lobster Nebula. Well, I guess yeah, it could be
I
a lobster,
did not
couldn't it?
know.
I did not know that. Looks like a lobster with one claw, maybe, but
Well,
Yeah.
would that be the Atlantic lobster or the spiny lobster?
I do not know that. And
Because
the
this
other
looks
ones,
like a lobster tail down here.
yeah, it does. Yeah, I would say that's probably, and I would
One
say
claw
up there, probably that's a claw. Yeah. Also, it's called the Checkmark Nebula. I don't see a check mark there.
Yeah, I'm not quite sure that one.
No,
Oh yeah,
I think it's
maybe flip it upside down.
maybe,
might be
yeah,
a check
upside down, maybe. Maybe.
Hey, everybody stand on your head.
Turn your screen.
Yeah, it's illuminated by about 35 hot young stars that form an open cluster embedded within the nebula. So this is just gas that's being illuminated by all these hot young stars in the center of it. I guess they'd call this a stellar nursery, would they?
Yeah, I guess. Well, I'm fascinated by the detail in the gases itself. You see twists and turns and the darknesses and it's just so. I wasn't expecting to see that kind of detail.
Yeah.
My backyard.
Out of your backyard, that's right. Its reddish color is the result of hot hydrogen gas being illuminated by newly formed stars in the nebula. Now, M17, which is Messier 17, Charles Messier, named after him, I guess, contains a large amount of dark obscuring material, which is also heated by the hot young stars and can be seen in infrared wavelengths. Now, the Omega Nebula contains about 800 stars in total. About 100 of them belong to a spectral class earlier than B9, while 9 of them are type O stars. That's the age of the stars and their temperature. There are also more than 1,000 stars being formed in the nebula's outer regions. M17 contains far more newly formed stars than the Orion Nebula. The stars in the Omega Nebula do not readily appear in images, but are hidden within the nebula.
Cool.
35 massive stars responsible for the nebula's glow are each 20 to 30 times more massive than our sun and about 6 times hotter. Now, their ultraviolet radiation erodes the dense cloud in which they were formed. The cold hydrogen gas clouds are heated and shaped by the radiation, and the pressure causes some of the material on the surface of the clouds to stream away, creating an intricate structure then obscures the clouds in the background. The nebula's glowing gas will eventually be completely eaten away by the radiation of the newly formed stars and leave behind a small open cluster. The open cluster within the nebulosity is one of the youngest open clusters known. It has an estimated age of just 1 million years. That's very young for stars, yeah.
Wow.
Only 1 million years old. Just babies.
Baby.
Just little babies. And M17 can be seen without binoculars in good viewing conditions from locations that aren't too far north. It is located roughly 10 degrees north of the teapot asterism, which would be about 2 fists width if you could hold your fist out, and 2 of those would be about 10 degrees.
That's a tongue twister. Fists with.
Fists widths, yeah. 2 widths of your fist.
Dweeb.
All right. So we've got a live view of a nebula, and there are many, many nebula, of course, in the sky, many of them in that direction of the sky as well, just because, again, we're looking into the areas where stars are forming. Let me take you off a pin screen here, Mike. Bring us back. There we go. We're looking into areas of the sky where stars are forming, especially into these areas. And nebulosity are large clouds of dust and gas that are either left over remnants of dead or dying stars, or they're the birthplace of new stars. And there may be enough material here, like it said, that a lot of these stars will eventually get rid of, the radiation will stop, and this clouds of dust and gas will dissipate. And we'll be left with an open cluster of stars, which we know many open clusters in the sky. Pleiades is one of the most famous, I guess, with nebulosity all around the stars, young stars. Rotate it 90 degrees counterclockwise for the check mark. Oh, okay. Thanks to CDB. Appreciate that. Rotate 90 degrees counterclockwise for the check mark.
Yeah. In other words, the long part will be facing from bottom to top almost.
Right.
Looks like a inverted L.
Tammy says, I'm behind. What is the Milky Way looking spot? We're looking right now at this cloud of dust and gas called the Swan Nebula. And we're looking at into the area of the Teapot asterism, which is Sagittarius, which is in our southwestern sky right now for us. But it's usually high in the southern sky. Not really high, not really that high for us in the summertime. So hopefully that answers your question, Tammy. There's a shooting star in this photo where you are seeing the Swan Nebula. Shooting star. Well, there's...
You might have seen a satellite go through.
Oh, maybe.
No, you
No?
No, you wouldn't, because that's he's just live stacking.
Okay.
Yeah.
So you wouldn't see that live.
Yeah, so the swan we're seeing, Marlene, is right here in the middle. If you can picture that as being the swan, this is the head of the swan, this is the body. So it looks kind of like a swan, so that's why they're calling it the Swan Nebula. And this is this big cloud of, actually you can see it extends out here quite a ways. This is this big cloud of dust and gas where new stars are forming right now. All the stars in the center in this area here are about 1 million years old, just baby stars. Our sun is about 4.5 billion years old. And these stars are so hot and luminous that they're lighting up this large gas cloud around it as well. And eventually this gas cloud will dissipate and you'll be left with a grouping of stars, what we call an open cluster. But this, we're seeing this view, it may already have happened because this is 5,000 years old as well, right? So.
True.
If you want to, Chris, I've got on Stellarium, I've got that up so I can show them exactly where it is.
Sure, absolutely, please.
You want me to stop sharing, Paul?
Yeah.
There we go.
Yeah, so Tammy, we weren't looking at the Milky Way in particular. We were looking at a location in the Milky Way. Of course, we're inside the Milky Way as well, but we're looking back towards the center of the Milky Way for that object. Paul's going to bring it up here for us.
Here, can you see it now?
It is. Could we zoom out a bit?
No, can you see it?
Oh, yeah, I can. Yeah, absolutely. Yep.
Yeah, okay. So I'm just going to,
Perfect.
if you want to talk through it, you go ahead. I'll just kind of guide you around.
Sure. So we're looking at the teapot of Sagittarius there. Can we bring on your artwork, Paul, just to represent?
Well, there it is, right?
Oh, I meant the artwork. I'm sorry, on your Stellarium.
Oh, sorry. Yeah, I can. Yeah.
There we go. There. So there's Sagittarius right there, the archer, right, and he's shooting his arrow into the scorpion, Scorpius. And of course, Sagittarius is one of the zodiacal constellations, which follow the line of the zodiac, that line that the sun and the moon and planets seem to take across the sky. We can see Saturn and Jupiter right there too in the image, top in the top left and right there. Yep, right there. So that's Saturn and Jupiter that are sitting, and they've been hanging right around this shape, right around Sagittarius all summer long. Well, I guess all since about the spring. And this whole constellation, see how low it is on the sky right now for us. We're only into, I guess, 10 to 9 right now, and it's still fairly low. And it's getting a lot lower, starting to drift off into the southwestern part of the sky early evening now. And we can see there's the shape of the Archer. But if Paul takes the artwork off in a second there, we can see that there's something that looks kind of like a teapot shape. So that's the handle of the teapot. And then we've got the lid at the top there. 3 stars to make up the lid. And then we've got the bowl underneath. And then we've got the spout coming out the side there. And we used to say, well, coming out the spout, all that steam is the Milky Way. You guys must have said that before.
Every time.
Every time. So if we look just off to the where the point is off the end of the spout there, kind of looking off into the center of the Milky Way, right around that area, yeah, right. That's where we're looking at the tens of billions of stars that make up the center. So we're looking back into the Sagittarius arm. So there's lots of stuff in here to take a look at, all kinds of detail and all kinds of really beautiful deep sky treasures to look at through that part of the sky. Take a pair of binoculars and pan through that part of the sky. You would be amazed at what you see, and you'll get to see these dust clouds like this in here. There's one especially nice. The Sagittarius star cloud is one of my favorite there, right there, yeah. And down below, of course, is all the nebulosity. So there's lots of these areas of star birth that are happening in this location of the Sagittarius arm.
So if you look up above that Sagittarius cloud, what Mike was focused on tonight, which is M17, that's it right there. Now, I'm going to blow that up so that you can see actually how much of that nebula that Mike was actually exposing with his camera. You were able to see all of this, all of that, and there's that check mark. This is upside down now, but there's the check mark there. And the 2 small light patches of nebulosity we were able to start seeing was right here and right here. Right. So everything that you could see right here that I'm moving my cursor around with, that's what Mike was showing you right from dead center in the city.
Right.
Unbelievable.
Awesome. Thanks, Mike, for that. We're going to move on, guys. We're into 5 to 9.
Yeah, we are.
So maybe I'll quickly pause and do a few photo submissions. Paul, you're ready to go with an object maybe, or do you want to do Rosanna's talk? What would you like to do?
No, I'm just going to do one or the other, so I'll just do a live view.
Okay, so I'll take a minute here, then I'll bring up our photo submissions that people had submitted for us. Represent now. We'll just take a second here and go through those. There's not too many. And I'll get back to full screen. And if I can find them over here, just a sec. One of my 15,000 tabs open. Okay, so I'm gonna get my notes out here too, first of all. Here we go. So you're able to see that?
Yep.
Okay, great. So this is the photo that was sent in by Emile Cormier at the Chicken Coop Observatory in Bactouche. Emile, Chicken Coop salute to Emile. He says Mars from the night of October the 5th. He says Syrtis Major appears prominently. I'm going to get my mouse. Where is my mouse? There it is. Man, I can't seem, no matter how big I make that mouse, I can't seem to follow it. There it is. Nice shot. Mars from the night of October the 5th. He says Syrtis Major appears prominently in the top right quadrant. Sinus Meridiani and Sinus Sabius are the long, thin features along the left side over here. The southern polar ice cap has shrunk considerably in the Martian winter when it's summer in the southern hemisphere. He said he captured this with a 10-inch SCT telescope and an ASI 224 planetary imaging camera. And this is a stack of the best 2,000 frames out of 36,000 frames. So obviously he's using a video. He's capturing frames at, I don't know what your rate normally is, Paul, on capturing something like this. How many frames a
Mhm.
second would you capture?
I think he was trying to get somewhere around 100 and some frames a second.
100 frames, 7 frames. So he captured, these are the best 2,000 frames, so his best 20 minutes, I guess. Out
Yeah, he would
of,
have captured somewhere around 30,000 frames,
mm,
and he took it down to the best 2,000.
yeah. So this is what you can do. See, it's really difficult to shoot a planet or capture a planet with any kind of detail at all because of our seeing conditions. Um, so this view would be snapping back and forth and up and down, boiling, bubbling, all kinds of stuff, and the software can discard a lot of those frames and captures the best of the bunch and then stacks them all together like Mike was doing there with his image, and we come up with a detailed image like this of Mars. Still waiting for a night, he says, with steadier seeing, but this is the sharpest I've ever captured Mars so far. It helps that it passes fairly high up in the sky compared to the last apparition in 2018. That's an amazing shot there, Emil. Very well done. Thanks for sharing that with us. Lots of
That's
detail there.
fantastic.
Yeah.
Yeah.
Mars is a tough one, isn't it? It is a tough target to get. Even though it's the next closest, it doesn't, I don't know if it just doesn't reflect a lot of light like Jupiter and Saturn do, or, but it's certainly captured it well there.
Yeah, the biggest thing is the seeing.
The
If
seeing.
you're fighting seeing, you'll never get a good image. So if you got to get a really good steady night.
Yeah. Okay, we've got a couple here from Trudy Allman. Trudy, this spot is on the way to Garden Settlement, I guess. Split rock, we call it. And there's why, because it's a split rock. But she captured a sunrise down there. And she says a few things need to happen to make this work. Let's scroll through the pictures here first of all. She got it just in the right location. There it is
That's
rising.
perfect.
And there it is, final shot. And here's the four all together. So this takes some planning for sure. A few things need to happen to make this work. The sun or moon lining up with the split. Sometimes tides, as I have to walk out to the low tide mark, and of course the weather. A lot of times there is a band of fog sitting on the horizon. Minimal gear, because if you leave something at low tide, it won't be there in a few hours. Good point. Sturdy tripod, a kit, and a zoom lens, and a flashlight. It's not fun to walk a long distance over the rocky ocean floor lugging camera gear with a cell phone flashlight. I know because I've done it, she says. When you're set up for a moonshot, it's still light out. So not so much when you're done. She says, I use the photographer's ephemeris to determine where to do my photos. It gives me a GPS coordinates for where I need to be, so I enter that as a waypoint and set it up in that location. I then watch for a glow as I may need to move. As the sun or moon rises, I need to move inland to keep it centered, and then remember to quickly reset the focus as I shoot manual. This all happens very quick, and that sun comes up very quick. Sometimes by the time I reset the focus, I have to move again. And don't forget to check your photos, because as it gets brighter, you need to adjust your camera settings, he says. So all true stuff, and all happens very quickly. That sun rises in seconds. Really is amazing how quickly the sun does rise when it gets to the horizon like that. But well done, Trudy.
Yeah, good job.
Oh, absolutely.
Excellent capture. Always a nice spot to get that shot. Carol Bean sent us in this one, the view from Mars from St. Stephen as it rose on the night of the harvest moon. Just a camera on a tripod, she says, no telescope. How bright Mars is there in that shot. And another one here from Andrea Loader, Mars on October the 7th, she says. So it is a very bright target right now, and of course we're coming up to opposition in 2 days, so that's when the sun, the Earth, and Mars are all lined up together, and so we're still got some time to enjoy that really bright object Mars. And thank you for the photos. That's all we have. So we're back to our meeting, and Paul, if you're interested in sharing.
Yeah, I'm just trying to make sure. Just give me another minute or so.
Okay. What are we going to talk about for a minute, Mike?
Talk about a wild duck.
Boy, what a quiet bunch tonight. I don't know. Did you guys not have your turkey dinner, or maybe you did have your turkey dinner? That's what's going on. Huh?
If you want to talk about a wild duck,
Sure. You got the wild duck?
there's a wild duck cluster if it comes up here.
Okay. First of all, I want to know why you call it the wild duck.
I ain't answering that. Not live in the air. You know that's not what I call it.
I know.
Should be there.
Yeah, it's M11, Messier 11.
Take this out of the way.
Messier 11, a wild duck cluster. How that looks like a wild duck, or a bunch of wild ducks maybe, or I don't know.
Some say there's a V in this area right here, kind of like that,
Okay.
and it's supposed to be the ducks flying in a V, but I don't see it.
So why is it a wild duck instead of like just a regular duck or Daffy Duck or
Donald
Donald Duck? Donald Duck, Daffy Duck? It's popularly known as a wild duck cluster. It's a rich, compact, open cluster located in the southern constellation of Scutum. Now, an open cluster is a group of stars that are bound together by gravity, but not as tightly bound together as, say, a globular cluster of stars that might be 10,000 to 500,000 stars in the ball. This one covers an area of 14 arc minutes, it's called, of apparent sky, and is believed to be about 220 million years old. 220, not 219.
What's a year?
Messier 11, this is called, Charles Messier, named after it again. Messier 11 is receding from us. It's receding from us at the rate of 22 kilometers per second. The wild duck cluster is the most distant open star cluster listed in the Messier catalog that is visible to the naked eye. And the cluster contains about 2,900 stars, which makes it one of the most populated open clusters known. It's also one of the most compact open clusters and appears as a diamond-shaped patch in binoculars, which I can see that. The brighter members of the cluster form a V-shaped triangle that could be said to resemble a flock of ducks when observed in a small telescope. And that's how it got its name. I would have called it a diamond cluster, or just here's a bunch of stars or something, but ducks, no, sorry. I don't go along with that one. About 500 of the stars in this cluster are brighter than magnitude 14. The brightest, hottest main sequence stars in the cluster have the spectral class of B8, giving them an estimated age of about 220 million years. The cluster also contains a significant number of red and yellow giant stars. You can pretty well see that there. Messier 11 contains 82 variable stars, many of which are pulsating variables, and what we call eclipsing binary stars. So one star passes in front of the other and it eclipses that star from our point of view. It was discovered in 1681. What did I miss? Emil says. What did you miss, Emil? Well, you missed your photo.
Well, I think we did a salute to him there.
We did do a salute. Well, Mike brought me into a target that I wasn't planning on describing, so I'm looking up some information.
Well, it was real close to the one I was on, so it was real easy to get.
Emil says, we thought open clusters were not gravitationally bound. I think they are just loosely gravitationally bound to each other. But, of course, globulars are really tightly bound together. So, Paul, how are you making out there?
Not good. Not good. You can continue on with the cluster.
Hmm?
You can continue on with the wild
Okay.
duck if you
Any questions about the wild duck cluster out there? Hey, Seacorn, Paul Richardson, evening.
Anything that would quack us up?
Peter says the Photo Pills app is another great tool for planning specific sunset sunrises. Thanks, Peter. I'll check that out. So again, another cluster of stars. It's one of the few open star clusters in the Messier catalog that has been observed by Hubble. Unlike many of the globular clusters Hubble has imaged, open clusters are groups of stars that are only loosely bound by gravity. The lifespans of open clusters are relatively short when compared to those of globular clusters. This is because the gravitational interaction between the members of the open clusters are comparatively weak. So stars do not remain bound for very long. They are drawn away by stronger gravitational forces. Now M11, Messier 11, is the most distant that can be seen with the naked eye, the most distant open cluster.
I don't know how you see it. There's so many stars in that area.
It's just flushed completely with them, right?
It is. I can't pick it up naked eye anyway.
The best time to spot the cluster apparently is in August. It is one of the most densely populated open clusters known, containing over 2,900 stars. What is the name of the cluster that looks like a question mark in the eastern sky? That would be the Pleiades star cluster, Kim. Yeah, so I'm going to try to maybe share my screen just for a sec, Mike, and I can...
I'll stop sharing here for a sec.
I'll bring over the view of... hopefully I'll bring over the view of Stellarium. All right, let me see if I can bring this over to you, and we'll take a look around here, Kim. One more screen to get over. Get over there. There it is. I think. Pretty well. Oh, come on. Get up there. There. Yeah, okay. So we were looking at the eastern sky, and we were talking about that cluster of stars. Let's take a couple things off here, first of all. We can get rid of the boundaries, I guess. And I think you're talking about this cluster right here, Kim, which is this one right here called the Pleiades star cluster. So this is how it would appear through most binoculars or small telescope. If you captured the image for a little while, you might get a view kind of like this. Paul's done that a number of times, eh, Paul?
What's that?
With the Pleiades.
Oh yeah, it's a gorgeous thing to capture.
It kind of looks like a lot of people call it they think it's a little dipper. Of course, little dippers are around the other part of the sky, but it follows up with Taurus the Bull. So usually you find the Pleiades, then Taurus comes up behind it, then Orion behind that again. So it is in the east-northeast part of the sky right now. It's saying time is about 9:10 or so. So it's up early now. Hopefully that's answered your question. And where were we looking at the wild duck? I guess we'll have to go back and search for that. M11. And here's where Mike was pointed just a moment ago at the wild duck cluster. Doesn't show up quite as nicely here. You can see we're into a constellation called Scutum, and just above Sagittarius there. So in the same part of the sky. So we watch for that, Kim. Now the Pleiades will be up, and it is a beautiful cluster in binoculars. It's incredible in binoculars. I love it. I love to sit and watch it in binoculars, right along with Andromeda when I catch it too. So, but it does stand out very, very nicely in our east-northeastern sky now, right around 9 o'clock. Okay, I'll pull that back again, Mike, out of the way, and I'll stop sharing. Mike has stepped away. Paulie, how you doing?
I'm doing good. I
Okay.
got nothing to show you though, but I'm doing fine.
You got nothing to show me, but you're doing fine.
Uh, I wasn't on the target that we
Okay.
were going to be on. Focal length is way too long for that kind of thing. So
You're set up for Mars. You're going to be doing some imaging on Mars later on, right?
yeah, later on will be. Yeah, right now it still hasn't cleared my roof. That's the other thing I was trying to get, but it hasn't cleared the roof from the
Yeah.
observatory yet.
Well, we've got all winter, guys, to offer some more double stars, so we will get into
Yep.
that part of our topic later on, I guess.
Yep,
Are you interested in doing Rosanna talk or?
we can do a Rosanna for sure. Yeah.
Sure. Okay. Kim says,
Okay.
I've captured in photos a couple of times. I couldn't remember what it was. Thanks for the info. My pleasure. And you can always just download the program called Stellarium. If you'd like to have it for your desktop or laptop, it's a free program. Stellarium. If you don't want to download it, they have an online version as well. It doesn't work quite as well, but there is a lot of points that you can bring up in it. Just go to Stellarium online, and you can check out the sky from your point of view on the web.
Okay. So
Okay.
I'll set up here. Just
For
give me momento. Just one sec here. And now
we are ready for
Rosanna's Fun Fact.
well done.
well, hello, Rosanna. How you doing again this week? So what we're going to do for Rosanna's fun facts for this week is we're just going to do a continuance of last week where we were talking about possible life on other planets other than our own. And so this week, last week we talked a little bit about what they saw on Mars and also what was possibly found out in the Crab Nebula out in Taurus. So this week we're going to talk about, I think it's this one here. There we go. And there's a nice, beautiful picture of Venus. And so this week's little tidbit on life on another planet goes like this. So astronomers may have found a signature of life on Venus. Evidence indicates phosphine, a gas associated with living organisms, is present in the habitable region of the Venus atmosphere. Now, the photo that you're seeing this is an artistic impression that depicts Venus. So this is not a real picture, but they've had lots of really good pictures of Venus, though. So the search for life beyond Earth has largely revolved around our rocky red neighbors, and NASA has launched multiple rovers over the years. And with a new one currently en route to sift through Mars' dusty surface for signs of water and other hints of habitability. It's a hard one. Now, in a surprising twist, scientists at MIT, Cardiff University, and elsewhere have observed what may be signs of life in the clouds of our other, even closer planetary neighbor, Venus. While they have not found direct evidence of living organisms there, if their observation is indeed associated with life, it must be some sort of aerial life form in the Venus clouds. The only habitable portion of what is otherwise a scorched and inhospitable world. Their discovery and analysis is published today in the journal Nature Astronomy. The astronomers led by Jane Greaves of Cardiff University detected in Venus' atmosphere a spectral fingerprint or a light-based signature of phosphine. MIT scientists have previously shown that it is stinky poisonous gas wherever detected on a rocky terrestrial planet, it could only be produced by a living organism there. The researchers made that detection using the James Clerk Maxwell telescope in Hawaii and the Atacama Large Millimeter Array, the ALMA observatory in Chile. The MIT team followed up with new observation with an exhaustive analysis to see whether anything other than life could be produced phosphine in Venus's harsh sulfuric environment. Based on many scenarios they considered, the team concludes that there is no explanation for the phosphine detected in the Venus clouds other than the presence of life. So it's very hard to prove a negative, says Clara Sauci Silva, who's one of the research scientists in the MIT's Department of Earth. Now astronomers will think of all ways to justify phosphine without life. And I welcome that. Please do, because we are at the end of our possibilities to show abiotic processes that can make phosphine. So this means either this is life or it's some form of physical or chemical process that we do not expect to happen on rocky planets. And I'll just finish up with this. So Venus is often referred to as Earth's twin, as the neighboring planets are similar in their size, mass, and rocky composition. They also have significant atmospheres, although that is where their similarities end. Where Earth is a habitable world of temperate oceans and lakes, and Venus's surface is a boiling hot landscape with temperatures reaching 900 degrees Fahrenheit and a stifling air that is drier than the driest places on Earth. Much of the planet's atmosphere is also quite inhospitable, suffused with thick clouds of sulfuric acid and cloud droplets that are billions of the times more acidic than the most acidic environment on Earth. The atmosphere also lacks nutrients that exist in the abundance of a planet's surface. So Venus is a very challenging environment for life of any kind to exist, Seeger says. So that is kind of what's going on out there with Venus, and that is this week's
Rosanna's Fun Fact.
Yay! It worked again.
Thank you, Rosanna.
Thank you, Rosanna. You're way too good at that, Paul.
I'm getting better.
I don't get any laughs anymore.
Yeah.
Your facts.
I'll have to start buttering up again, I guess.
Yeah. Well, guys, I guess that's probably our show for the night. We're at 9:19, so we call it a night. I guess we
Yeah,
will.
it's getting there.
Well, folks, again, in closing tonight, our special thanks for your continued support again, of course, and thanks again to Rosanna for her continued contribution to our show.
Absolutely.
Remember, too, we do love getting your photos, so send them to SundayNightAstronomyShow@gmail.com, and we would be happy to include them on our broadcast. We're also looking for suggestions for future topics for our shows. If you have anything you would like to discuss on us to discuss in a future episode, please send your request to the same address, SundayNightAstronomyShow@gmail.com, and we will do our best to make it happen for you. We also ask that if you enjoyed the content here tonight, and if you joined us from YouTube, please consider giving us a like and subscribing to our channel. And please let your family and friends know as well that we are here every Sunday night to educate and help entertain you as well on the night sky. And two, we do hope you'll be able to tune into our interview tomorrow morning on Global National. Again, that's the program starts at 7 a.m. Atlantic time, and we hope that you'll really enjoy it. And if you don't get a chance to see it and you happen to be sleeping because you had all that turkey last night or tonight or tomorrow night, whatever, we're going to try to share the link back on our Facebook pages to let you know about it. And we're just hoping that we know it was a lot of fun for us. it was a great time for us to be able to do it, but we'll see how it turns out. Anyway, we're really pleased that Global took an interest in us doing it. So that's what it's all about for us, more outreach. So for now, then, from Mike and Paul and I, stay safe, everybody. We wish you all clear skies, and we hope to see you all again here next week. And remember, guys, as we like to say, keep your scopes pointed up. Chicken coop salute.
Chicken coop salute.
Have a great week, everybody. Good night.
Good night.